Hello, Dr. Doyle. My name is Daniel Moore. I'm in your Introduction to Electrical Engineering. This is my presentation for my final project. I have the idea to create a system that can control one's shower a whole lot better. I've noticed in many showers that if you move the temperature valve so much as a millimeter, the temperature drastically changes. This is kind of a pet peeve of mine. But there's also a lack of pressure control and no water monitoring for conservation and health. So I was thinking it would be a great project for me to create such a system that can monitor all of this and control it. All right. So the basic theory is there would be a temperature sensor and pressure sensor inside the shower head that can monitor these things and feed back some input into a controller. I was thinking a Raspberry Pi, and maybe even in time I could use something that I designed myself, but it would feed back this information to a series of servo motors that go back to the nozzle or the handle that is controlling the system, or the temperature, I mean, and essentially adjust it so that you don't have to. Nothing's more annoying to me than, having a hair or a head full of shampoo and then suddenly the temperature changes and I have to adjust. It kind of drives me crazy. I think it would just be great to be able to punch in, say, I don't know, 100 degrees, and then the system automatically adjusts it to keep it at a consistent 100 degrees. I just thought that would be fantastic. But the basic design, the controller would control the water temperature, the pressure, and you can even monitor the duration of the shower too, so you have water conservation there. Also, I was thinking possibly about creating a system that actually monitors the content of the water, such as lead levels, pH levels, things of that nature. See if you've got hard water. I know that's a nuisance to a lot of people. Um, some of the things that I'm considering also is something to monitor the levels within your water heater. I know this actually is done quite a bit with a lot of modern water heaters, but I just think it'd be cool to create my own system, just, as a test to my abilities after I've gone through more courses, of course. But let's see here. Yeah, the electronics on the water heater would feed back information to the controller and the human machine interface about water levels, energy consumption, and once again, possibly water content, pH levels, lead levels, things of that nature, and possibly even contaminants, any contaminant they have in the water. So the controls, I'm thinking for the most part, at least starting off, using a Raspberry Pi. I've gotten comfortable using the Raspberry Pi. I've used it on a couple of little projects for myself. It does require some C programming, maybe some C++. The big thing is Python programming, though, and though it's not required in our electrical engineering degree, I have thought about actually taking the Python course. It's only an 8-week course, and I think it'd be really cool. Big thing is networking. I have thought about also making all of this voice activated. I always thought it'd be really cool if I could just say, "Hey, computer, turn my shower on," or "turn the shower off," or set to Dan's levels, or Dan's memory or whatever. Uh, Settings. There's the word. Also, what I love about the Raspberry Pi is it's cheap. It's very inexpensive, as you may or may not know. It's only like $35. So, and it's already somewhat pre-programmed. It's got Raspbian in it, and it also has Python already in it. It's quite versatile. But as a challenge, I may create my own controls circuit board. I think that'd be very challenging. It would be very interesting, though, and it would be very educational for me, of course, to create my own circuit board. I think that'd be fantastic. So, oh yeah, there it is. Yeah, this is my idea for creating my own circuit board. So, um, it would be a challenge, but possibly by the end of my studies, I would feel comfortable to do so. Hopefully, let's hope. All right. I do have my 32-week plan and the courses that are going to be required. The first 1 through 8 weeks is finding the right electronics, basically the bill of materials. It would be at least two servo motors, one for temperature control and one for pressure control, two valves, one for temperature, one for pressure, one water temperature sensor. I'm sure they've got something out there. that is designed for water monitoring, as well as pressure. There's one pressure sensor. Whatever wires are needed, I don't know what gauges they would require. Probably mostly just controls, so it'd be maybe a 22 American wire gauge. The control circuit board with an HMI, human machine interface, once again, Raspberry Pi or a homemade circuit board, whichever works. And then finally, a gauge or sensor of some kind for the water heater levels. And then possibly, actually, one thing I forgot to add to this is the any kind of sensor that could monitor the content of the water, lead levels, pH levels, et cetera, et cetera. So I thought that would be a good start to everything. Weeks 9 through 18 would be essentially designing the layout of the system. The temperature and pressure sensors will go at the top of the shower head where the water can be monitored. The gauge or sensor for the water tank will be next to the water tank, or actually inside the water tank. And the controls with an HMI will be next to the shower. One thing to consider is a kind of waterproofing. Obviously, we're dealing with a wet area, it's a shower. So one thing I've considered is I'm going to have to waterproof several things, possibly create some sort of waterproof casing for the motors, and maybe any wires or anything. But that's one thing I'm definitely considering. Some courses needed would be the fundamentals of mechanical engineering. Obviously, with valves and any moving parts, it's more mechanical. And then measurements and instruments that goes to the sensors and any kind of gauges or anything like that. So that needs to be considered, of course. I have, let's see, for week 19 through 26, this is going to be the meat and potatoes. This is going to be the programming of the system. Any loop statements, if-then statements, control readouts, inputs and outputs programming, all the logic that's going to go into it. And some of the courses that will really help me out is, of course, Introduction to Engineering and Computing. Obviously, that's the basics of it. Some electrical circuit analysis that goes into, especially if I create my own circuit board for my controls. Continuous and discrete signals and systems, control systems and theory and design, microcontroller based systems. That's going to be important because there's going to be a lot of bits and decision making through the logic and the bits. And then the Python programming, it's not required by our course of study, but I've thought about taking it just because I want to do a lot more with the Raspberry Pi, and Raspberry Pi is very heavily into Python programming. So it's only an 8-week course, and I'm eligible to take it after the Introduction to Engineering and Computing. I just think it would really help me out, and especially in a lot of my personal projects that I'm trying to do with the Raspberry Pi. Right now, well, this is kind of off topic, but I'm creating an arcade system with a buddy of mine, so we're going to be using the Raspberry Pi. Weeks 27 through 32 is actually going to be building the system. It's going to be physically the hands-on portion. I'll be putting in or installing the sensors into the shower head. I will be messing around with the valves, installing the motors, anything of that nature. Be doing any troubleshooting, any debugging, possibly even some minor redesigns as necessary. And some of the courses required for that will definitely be mechatronics because I'll be working with electrical motors, turning valves. So, and then also some embedded system designs. That's going to be really important as well. Some things to consider. What plumbing knowledge do I need to know? I may even need to consult with a plumber, possibly. So that's one thing I'm considering. What fluid dynamics do I need to know? I mean, I might be going over some of that in my physics courses and maybe even some calculus courses, but that, I believe, to my knowledge, to my limited knowledge, fluid dynamics is a little more mechanical engineering for the most part, but it's water, so it should be pretty standard stuff. And then what information do I need to learn about water heaters? I've installed and removed and replaced a water heater, but I don't really know exactly how they work. So I'm definitely going to have to do research into what goes into the creation of a water heater. That's going to be interesting. That's going to be very interesting for me. But needless to say, I feel this project would be fantastic for me because I am going to be going into controls engineering. I'm going to be designing things that are going to require programmable logic controllers. I think it'd be fantastic if we had a class in PLCs. That'd be great because they're going to be huge in automation over the next 20 years, 30 years, give or take. I think a lot of this is going to culminate in a great project that is going to involve almost every class I'm going to be taking in this electrical engineering program. It involves mechanical, involves controls, involves programming, obviously all the electrical stuff. I have also thought it would be amazing to make everything voice activated. It would be great to just wake up in the morning and say, "Hey, computer, turn my shower on," or "shower on," and set to Dan's levels, or set to Dan's whatever presets, I guess you could say. Um, Something like that is actually going to get incorporated into basically, I'm going to be turning my house into my own smart house. I'm going to be doing a lot of little putsy little things, little projects to create everything, almost everything, voice activated. And I think it would just be great if this was attached to that overall major project with my house. So this isn't quite 15 minutes. Kind of plowed through everything faster than expected, but um, this, I think, would be a great project for me, and I think it would definitely incorporate everything within the electrical engineering program. But let me know what you think. Please give me your feedback, and I thank you for your time and attention. Bye.